Kiefer Creek is a small tributary to the Merrimack. It's located in southwest St. Louis County and it flows southeast through Castlewood State Park. It's fed by two of the largest springs in the county, and last year during the drought it never stopped flowing. It flows through Castlewood State Park, which is one of the nicest parks in our area. It has bluffs that look out over the Merrimack and vast tracts of conservation land. It is a great place for hiking and mountain biking. It's a great place for bird watching. It's a great place that's only, 20 minutes away from you if you're in Dogtown. So you're able to get from the urban area into this very beautiful rural setting really quickly.
Everyone lives in a watershed. A watershed is an area of land for which water drains from it. So, we're in the Mississippi, Missouri River main watersheds with several smaller subsheds broken up with all the, such as Kiefer Creek, that discharges the Merrimack and discharges into the Mississippi River.
A watershed is a litmus. Everything that happens on the land usually winds up in the creek. Everybody lives in a watershed, unless you live on a boat, in which case you live on a water body.
There has been a lot of education over the last 10 or 12 years, not only in St. Louis, but really across the country, around watersheds and the importance of looking at the entire drainage basin of a river when you want to think about the water flowing in the river.
Kiefer Creek watershed's a very special place. It's got more forest for a populous county than most of our other watersheds. It's less developed, has more natural flow, a lot of beautiful karst features, including a beautiful Kiefer Spring right here. And we got perennial flow in this watershed and a lot of protected land just downstream of us, particularly Castlewood State Park, one of our really beautiful parks in the county. It's almost 3 square miles. And upstream there's bluebird parks and smaller protected parcels. So this watershed's pretty well left alone compared to the metropolitan area.
Comparing Kiefer Creek to some of the other creeks in the area is really kind of interesting because it really does seem to correlate with the amount of development there. Grand Glaze Creek, which is nearby and runs down into the Merrimack, and Fishpot Creek, which runs down into the Merrimack, just a little bit downstream from here, and Kiefer Creek are all urban type streams now. But Kiefer Creek has higher quality water right now than Fishpot Creek does. Fishpot Creek has deteriorated quite a bit in the last 10 years or so, and Grand Glaze has too. But they still have a lot of organisms in them. They're not completely dead, but they don't have these marks of high quality water in them that Kiefer Creek still has. And Kiefer Creek still has a lot of watershed that is undeveloped, and a lot of trees and forested areas and field areas that do a lot of filtering of the water coming in. Some places like Fishpot Creek now has development on both shores all the way up and down it mostly, and it's pretty tough to keep that environment natural,
Most people in the community who are familiar with Kiefer Creek first experienced it in Castlewood State Park, where it flows right through the heart of the park. There's a swimming hole right off the road and a picnic area and pavilions right there. And so during the summer, on hot days, you always see people out there playing in the creek. It's an area where there's always kids and dogs wading, swimming. It's amazing to me how many people in the community come out when there's all these great swimming pools and they decide to go to Kiefer Creek and go for a swim.
Well, Kiefer Creek is a special tributary to the Merrimack, in part simply because Castlewood State Park is at the mouth of Kiefer Creek and on the Merrimack. And so you get thousands of people coming to that park and hiking, wading in the creek, swimming in the pools of the creek, swimming in the Merrimack River. It gets a lot of public use, a lot of public pressure on the park because of its popularity. And the creek then is an important resource for the park, of course. And it's important for us to think about how to both manage the park and the land around it so that creek remains as healthy as possible.
If you go down into the watershed, every subdivision is named after Kiefer Creek this, Kiefer that, or Castlewood, So there's a really strong identity in this area. You actually have streets that are named after natural features that are actually there. Kind of rare thing in suburban development.
We moved out of West County in the early 70s, and I started teaching at Parkway South in 1976. And that's when I found more interest in it, because I brought my students over here for field trips and to do water quality studies and other environmental things. So it was a great place for a field trip and nice and close to Parkway South. And so that's what really got me interested in it.
You know, like indigo bunting, really colorful little bluebird. That's like a neotropic migrant. White-eyed vireos pretty much stay within this field. You usually won't find them in the woodland part.
Kiefer Creek I think, is a phenomenal asset to the people that live around here and to the students that are close by, because it's so convenient and it's a pretty pristine environment, at least it used to be, where you could actually have students close by come to this environment even on a weekend, and they got a beautiful stream to which to be part of and play in, and they can learn so much about pretty wild ecosystems here because it wasn't developed, and a lot of students did that. But I introduced a lot of students to it. A lot of the students from Parkway South live pretty close. They didn't even know this place existed, and so it's really an asset for teaching them about ecology and watersheds and streams and biology of the area, and about the Merrimack River. And so there's just a lot of assets or resources available for education for all the people in the environment.
One of the neat things about Kiefer Spring watershed is it's almost entirely underlain by carbonate rocks. The predominant formation is the Burlington Keokuk limestone of Mississippian age. Now, the Burlington Keokuk in other parts of the state is one of the most cavernous and has some of the most sinkholes. One that has a lot of groundwater transiting through it. That water is coming out here, some of it in Kiefer Spring. There's other large springs in the watershed nearby, also in the Burlington Keokuk Formation. There's an equal size or bigger spring called Sontag Spring, just to the west of us. That whole branch of Kiefer Creek is called the Spring Branch. And there are many springs. I know of two others in that branch that are a substantial size. Anyway, water sinks into the ground and comes out, and it's all filtered and nice and cold and clear.
I think the most surprising part about the Kiefer Creek watershed is it doesn't look entirely polluted, which can be deceiving to a lot of people. You see people swimming in it often, and I think people think because the water runs clear that it isn't polluted with fecal bacteria or chloride, but that isn't the case.
You know, Kiefer Creek is different from a lot of the other streams in St. Louis County and in the area. It's one of the first streams that you encounter as you head west that's still nice. And it experiences some flash flooding, and it backwater floods from the Merrimack. But when you compare it to creeks like Fishpot, it's in incredibly good shape. And it's no wonder, you know, you can look at the forest cover in Kiefer Creek and see that it's heavily forested. Fishpot, the forests have been decimated.
In 2007, I used this stream as a swimming hole for my dog, Dolphus. Dolphus is a giant schnauzer. And after several weeks, Dolphus started getting ailments. He had black eye discharge, diarrhea, and boils that developed on his back.
Steve had hiked the watershed and driven around. He lives in the area, and he noticed that there was a USGS monitoring box along the banks of the creek. And so he went online and he looked to see if there was any water quality data that had been collected over there. And sure enough, he found 49 samples that showed that Kiefer Creek had extremely high bacteria levels. So it was about this time that Steve came to us, the Missouri Coalition for the Environment, with his findings on Kiefer Creek, and that's when we really started working on the project. Our first goal was to get Kiefer added to the impaired waters list, which is a list of waters that are too polluted to support uses like swimming and aquatic ecosystems. So we went to the Clean Water Commission and we asked them to add Kiefer Creek to the list, but they said that our data was too old and that it was from the unclassified segment of Kiefer Creek. So we went back to the drawing board. We looked for some more data, and sure enough, we found data that showed that Kiefer Creek is still impaired. And so we submitted this data in a comment and got Kiefer Creek added to the 303D list in 2010 for bacteria which impaired the recreational use of swimming.
One thing we learned also is that bacteria is from stormwater runoff because MSD does not have any sanitary overflows within the Kiefer Creek watershed area. And also we have sampling data that show that the bacteria does exceed water quality during and after storm rainfall events. So it is an issue there. Non-point source pollution is from everything else, from just general construction sites, the runoff from that, the post-construction runoff from that site, such as from the parking lot, the roof, from that site, from residential property owners, the general runoff from that.
I'm no scatologist, but think of somebody walking a dog down a street, that manure is going to be washed right into the receiving waters very, very quickly. That's different than deer in the woods where you have leaves and stuff, and that material will go into the soil. There's all kinds of scavenging organisms, fungi and bacteria that will decompose it and deal with it pretty quickly. So it's a totally different process.
We actually walk the stream up and down, and we've found failing septic tanks and also animal waste, such as from farm animals, right in the creek itself. So, and that's the source of bacteria.
In 2012, new data came to light, and it showed that Kiefer Creek was in fact also impaired by chloride, which means that it can't support an aquatic ecosystem because it's a freshwater stream, and when you get all that salt, it kills everything that needs fresh water to live.
Surface runoff's the worst. Of course, you got all kinds of pollution: road oils, road salt, just animal feces, detergents, any septic leaks, just all this stuff just collects and delivered to the stream channel. There's no filtering, and so surface runoff is very bad water quality.
The thing we just typically don't think about in a developed environment is that in a natural forested environment or even a prairie environment, when rainwater would fall, it would be delayed by the plants before it even hit the ground. And then after it hit the ground, it would tend to sink into the ground, follow the roots of the plants into the ground, and it would therefore recharge the groundwater in a way that doesn't happen when you have a lot of pavement, a lot of impervious surfaces.
We're seeing some of the impacts of development on this watershed. Again, they're subdued compared to a typical St. Louis County watershed, but there still are obvious things we can see. More development, be it yards and certainly roads and rooftops, shed water more quickly to streams. There's less infiltration in the ground. There's less evapotranspiration by the trees.
I think the biggest problem we face today is really stormwater runoff from developed areas. And including in that are the pavement, the rooftops, the parking lots, etc., that come with a built-out environment where stormwater running off of these paved surfaces rapidly enters the small tributary streams and then, of course, flows into the Merrimack itself. And you get that flash flooding, high water levels followed by low water levels. And it's a serious problem that can be addressed only by the actions of many people in their individual homes and businesses, the property they own, beginning to look for ways to control the stormwater that falls on their land right there where it falls. That is, creating opportunities for water to sink back into the ground as it would in a natural environment.
The area was really quite different and it wasn't near as developed. I used to ride my bike down Kiefer Creek Road all the way, and there were practically no houses on Kiefer Creek Road in this whole valley down here. And all that changed over the next 15, 20 years to many subdivisions, and really changed probably the nature of the entire watershed.
You can see evidence for flash flooding all around us. For one thing, the cobble size is too large for a creek this size. This is pretty coarse gravel. This should actually be more fine material. And creeks that are really impacted by flash floods, you got boulders everywhere. They're just really big stuff. But this stuff is too coarse. You can see evidence for widening of this stream channel. And there's a bunch of roots showing over here. There is widening and erosion, and there probably is down cutting of the channel, entrenchment of the channel.
As a kid, you'd walk along the creek, you know, and a particular snake called a bandit water snake, you know, they were a dime a dozen. Now if you walk a mile long stretch of this creek, there's a very good chance you won't see one. You know, the reason for their disappearance, you know, it's probably several factors, but it's kind of a bummer. Other common snakes in other areas, you know, like your black snakes, green snakes, you know, you just don't find them in here, unfortunately, anymore.
Well, urban creeks would have much fewer fish species, maybe 5 to 10, for example. And the species that do survive would be very tolerant of urban conditions, which are usually degraded. So some of the species you might find include the central stone roller, the creek chub, the western mosquito fish, and green sunfish. And sometimes bluegill and largemouth bass might be found in urban creeks, but generally they've washed downstream from a pond during flooding, for example. Native mussels are usually completely absent. You might also find some tolerant species of crayfish and aquatic insects that may survive as well.
I can remember when both sides of the valley was just intact, unfragmented woodland. Now that's all been built up, so the ever shrinking supply of woodland for birds to utilize, it kind of bottlenecks them in here. It affects populations. Some just disappear. It used to be found in the creek, and you just don't see the amount of fish like you used to either. And there'd be in schools of this type of fish called a hog sucker. That's like a bottom dwelling fish, like this big.
Yeah.
I mean, 20 or 30 of them just,
Scooting along.
Yeah, it was incredible. We'd have our nets, we'd catch them and let them go and stuff.
Do you think the flow has changed?
Yeah, I mean, one thing, like I was telling you at that meeting, that I remember were more deeper holes, and now it just seems to be, I mean, there's still some good holes, but now a lot of it, there's long stretches, of shallow, maybe a foot or so deep.
Primarily we're talking about nitrogen and phosphorus, which are found in a lot of fertilizers that we use, especially in a highly suburbanized area like this. We're talking about nitrogen and phosphorus, and those are both necessary for plant growth, but too much of those things can lead to something called eutrophication in our waterways, which it allows certain aquatic invasives to thrive because it's a nutrient-rich environment, and that can lead to depletion of the oxygen level in that waterway, which then affects all the other aquatic life that depends on the health of that system to survive.
The worst oxygen problems, the DO problems, are in the summer with hot water. It's not only because oxygen is more soluble in cold water, just it's a physical temperature effect. But again, if the water is hot and you're growing a lot of algae, then you get a lot of decaying matter and stuff that can really run the oxygen levels down very quickly.
Lawns, for example, are very resource intensive, so there's a lot of resources used to water the lawn, to keep it green. There's fertilizers and pesticides that are added. Lawns also have very shallow roots, so stormwater or rainwater per se hits the turf lawn and it runs off just like a parking lot.
Where new subdivisions have been put in this watershed, many of them don't have a proper riparian border along the creek. There's just grass right up to the road or to the creek. And we need plantings along the creek, both sides, anywhere that's done, and you need a wide border to slow that delivery of water down. Rather than running storm water from rooftops and new streets through pipes right into the main channel here, we need some detention basins to slow that delivery down. Rain barrels would help do that on individual homes. There are those things that we can do. Where we have erosion, we ought to be thinking about willow stakes, not cement walls.
There has been a lot of education over the last 10 or 12 years not only in St. Louis, but really across the country around watersheds and the importance of looking at the entire drainage basin of a river when you want to think about the water flowing in the river.
You know, if we want to live in a planet with biodiversity, if we want to have clean water to drink, clean water to allow our kids to play in, clean water for swimming, clean water for boating and kayaking, then we have to protect our watersheds. And if it's not important, and if the water we drink isn't important, and if the opportunity to spend a day on the river isn't important, then we don't need to protect our watersheds. But to me, those things are really important, and I think to a lot of people in Missouri, you know, we really value our rivers and streams. We have some of the most beautiful rivers in the country, and we feel lucky to have them. And I think that it's our job, in a way, to take it upon ourselves to be good stewards.
Yeah, it's a very valuable park and creek, and people can really relate to it. You know, people around here have been like, oh yeah, I've been going to Castlewood since I was 2, you know, and now they're starting to realize that there are issues with this place, that we need to be taking care of it, and we need to understand what's happening so that everybody can pitch in and do some good.
I think we have an obligation in our society to not necessarily think we can solve every problem, but we can certainly make the situation better. And that's what we work toward. You make the situation better, and everybody makes the situation better. Pretty soon, at least you stop the deterioration. To keep Kiefer Creek in the quality and the situation that's in right now, I think would be a great accomplishment. You may not ever get it back to the way it was, but where in the world are you ever going to get everything back to the way it was in the past? That's not very likely anyway. But if you can keep the quality that we have now and not let it deteriorate anymore through education or whatever, and good practices regarding how we landscape, I just think we're silly if we don't. And I think it's naive to think that we can't do this. I mean, people that throw their hands up and do nothing are really part of the problem.
So we realized that the regulatory framework was not going to fix the problems at Kiefer Creek. And we also realized that even the impacts that it may have would take years to really have any effect. So that's when we decided to do a watershed plan.
Planners are beginning to understand a lot more about the importance of looking at an entire watershed, an entire basin for a stream. And of course, when you do that, you can look at a lot of different levels. You can look at the Merrimack River. The 4,000 square miles is pretty big for any kind of planning. But then you can look at small streams like La Barque or Kiefer Creek, which are small and independent streams that are kind of manageable size, and when you have the possibility of actually talking to the people who live along those streams and organizing plans that involve the local residents in the thinking about the plan, the development of the plan, and then more importantly in the management and the work to carry out the plan for the long term.
There's a lot of things that you can do to improve water quality, but first you have to become conscious of the watershed.
I think a lot of people do live where they do because of the beauty of their surroundings. And I think if they were more aware of what was happening, they would take a stand on helping to stop the pollution.
When it came down to it, I needed to come up with a good way to get ecosystems restored and to reduce non-point source pollution. Those are the biggest problems that face our society from a water perspective. And so I saw that watershed planning, though maybe not the fastest process in the whole world, is a really good way to learn to understand the problems and then develop really smart solutions to deal with them. Through watershed planning and through bringing the community together around the watershed, hosting great events to talk about it, to teach people, working with students both as interns and doing presentations of the community to make people aware of these great natural resources. You know, that's really good work, and it's the way that we reshape the way that we treat the land and the way that we treat the water.
Yeah, I think the main component is being aware of your surroundings and being aware of the problems that's happening in your community and seeing how you can help on an individual basis.
There are a lot of impacts and there are a lot of problems, but if we can bring together the community to do good stewardship and to restore the functions to the ecosystem, the hydrologic functions. We can reduce flash flooding. We can save money on impacts to our infrastructure and erosion. We can save money on the cost of treating our water. We can save money on visits to the hospital when we get sick from swimming in Kiefer Creek.
I'm the hydrology intern, and myself and Jocelyn, the ecovisualogist, go out together and do site visits. And on a typical site visit, we will take measurements of the stream channel, take measurements of the water itself, including depth and width to get a cross-sectional area, and then also take surface velocity measurements, and from there I'm calculating flow to sort of get an idea of to figure out where the springs are, how much they're flowing, where the losing segments are, and sort of get a better idea of the hydrology of the watershed.
We have broken down the watershed into residential, and from there we've broken residential down into multifamily, single-family, parcels, duplex and townhome, and then we broke it down into commercial, industrial, utility, institution, common ground, vacant, and that really helps us distinguish which BMPs would be best suited for the different people within the watershed.
We started doing a lot of geospatial mapping, called GIS, where we add layers of data and maps together and figure out where the problems are coming from, so we can look at the total footprint of all the roads in the watershed and calculate how much chloride is applied to them.
There are smaller alternatives that you can take just as a resident, say a single family or multifamily, living within the watershed that will help the chloride problem within Kiefer Creek. And some of these are just using less salt in general, using maybe sand or gravel or birdseed as traction instead of throwing salt. You can also use agents that will de-ice that don't have chloride, and these are usually advertised as pet safe.
And then we can look at the number of horses or the number of dogs or the number of septic systems and where they're located in the watershed, and all these things are potential sources of bacteria.
When looking at different parcels or just institutions in which we try to target, we look at the amount of forest cover that they have, where they're located within the watershed, if they're located within the 100-year flood zone or 50-year, or if they're in a floodplain in general. We look at how much lawn they have and how much of that can be turned into riparian zone.
You look at best management practices or non-point source pollution management measures. And so that's things like stream stabilization and planting trees in the riparian zone, restoring wetland areas, trying to get better methods used for snow removal. There's newer systems out there and different chemicals that can be used. It can be less detrimental to the creek, and it's important to make sure that we're staying abreast of new technologies that could help us protect it.
One thing we hope to do as part of this work group recommendations is at least come up with educational material. Address septic tank, the maintenance, operation of maintenance, basic homeowner education. Big issue is property transactions. Someone buys a property, they don't even know if septic tank's there. Some lenders require it, a bank, but it's not a requirement.
Fixing a septic system can be very, very expensive. And there are people out there who are on fixed incomes, and it's a voluntary participation. So, we're looking for opportunities to work with people and to first figure out, is it septic systems? We know that they probably have an impact, and we know that there are probably some pretty bad ones in the watershed that we'd like to work with the stakeholders there to try to fix.
Maintain your septic tanks. There's a lot of older systems in the area, so just by homeowners making sure that they know that they have a septic tank, getting it inspected, having it pumped out, Septic tanks, when not properly maintained, will leach out through the field, untreated, and enter the creek, causing the elevated bacteria levels. And so you need owners can practice water conservation if you're in a septic tank. A lot of the older systems aren't designed to properly take on the water. They're undersized, and owners should watch out what they put into the systems, in the septic tank systems, such as certain chemicals that could upset the system. It is a biological process.
With karst, it's kind of hard to tell like what's happening underground because you can't see it, So, for example, a pile of animal waste sitting at the edge of someone's farm, even if they're not necessarily close to the river, to the creek itself, if that waste is sort of running off into a sinkhole, the sinkhole could give it a much quicker path to get into the creek than it otherwise could just sort of running overland.
For horses, it is advised to have a nutrient management plan. Each horse produces 8 tons of manure every year. So it's really important to know how to properly handle the manure so it doesn't run off and pollute the waterways that you live near. So some suggestions would be to keep it covered with a tarp or a shed, or as well as compost it, which means turn it regularly, make sure that it isn't too moist, make sure that the temperatures are right. The other is location. Make sure that when it does rain, it isn't located near, it isn't within a floodplain, it isn't near a storm drain or a riverway, so it can run off into the water.
Identifying your areas of natural landscape is very important when you're doing conservation planning. You want to preserve areas like floodplains, forested areas, riparian corridors, or wetlands, and make sure those areas are not developed. So by identifying those important areas of natural cover, you can avoid developing in those areas, and that will guide the areas where you should develop. In St. Louis, a lot of areas are already developed, so you might use conservation planning to determine where restoration efforts will be important. And Castlewood State Park is a really good example. We can use historic land use data to try to figure out what habitats were at Castlewood to see what type of efforts we should do in the future.
The best way to deal with habitat fragmentation is to avoid it through planning. Really, you have to plan in order to have corridors and some sort of connectivity between these fragments that are going to be left after the landscape is changed or altered. In a lot of cases in urban areas, it's too late to really plan for that. So we are trying to mitigate it. So we're trying to find corridors that we can improve. Riparian areas are especially key this way, and those are the areas along a creek. So about 100 feet on either side of a creek bank is the riparian area that we like to see as maintained in some sort of natural state so that animals can use it as a corridor from one fragment to another, because these waterways are frequently the way that these habitat fragments are connected.
I guess the first thing that comes to my mind is a lot of those riparian areas and urban suburban types areas are now mowed landscapes, whether it's residential or left open to common ground, things like this. We have this love affair with mowing, so just getting trees back in there to break up. Again, slow the water down. That's been the biggest thing.
Trees make a huge difference in returning water to the atmosphere, which reduces the runoff rate. Besides the roots that help to fend off erosion, and the canopy itself softens the rainfall as it comes down, slows things down. Another thing that's quite often forgot that trees just do physically is they have a lot of surface area. Look at the surface area of all those leaves compared to the surface area of the ground. When it rains and all that surface is wet, you've got that huge area from which evaporation can return water to the atmosphere.
Well, identifying your areas of natural landscape is very important when you're doing conservation planning. You want to preserve areas like floodplains, forested areas, riparian corridors, or wetlands, and make sure those areas are not developed. So by identifying those important areas of natural cover, you can avoid developing in those areas, and that will guide the areas where you should develop. In St. Louis, a lot of areas are already developed, so you might use conservation planning to determine where restoration efforts will be important. And Castlewood State Park is a really good example. We can use historic land use data to try to figure out what habitats were at Castlewood to see what type of efforts we should do in the future.
Recently, we planted 6 acres of trees in partnership with MDNR and Missouri Master Naturalists in Castlewood State Park in a very important riparian floodplain zone.
A lot of BMPs are really easy to implement, and almost anyone can do it. It just is a matter of fact if you want to change your lifestyle in order to do it.
How much do you have to reduce the problem in order to make it safe for swimming, in order to make it capable of supporting a healthy, diverse aquatic ecosystem